All right, I'm pretty sure I'm recording, so let's do this. All right, here we go. So guys, yesterday, the big takeaway from yesterday's notes was being able to look at a relation and tell whether or not it represents a function. If you're a function, then you have to have that function behavior that says when one number goes in, only one possible number could come out, right? So if 2 went in and 7 came out, I only want 2 to go back in and 7 still come out. If 2 can go in and all of a sudden 9 comes out, that's not a function. That's not function behavior. Each input only produces one output. That's what it means to be a function, okay? So if you're looking at a list of ordered pairs, then you can tell by whether or not the x's repeat is if it's a function or not. But if you're looking at the graph and you want to know, does this graph represent a function, then we have something called the vertical line test that will help you quickly realize whether or not it's the graph of a function or not. So the vertical line test says, or the VLT for those cool kids, if you can draw a vertical line anywhere over the graph and it only touches the graph one point at a time, then that's the graph of a function. The vertical line test proves that the x values do not repeat, okay? All right, so let's look at example 2. Example 2 says state the domain and the range of each relation, and then determine if each relation represents a function. So guys, look at A. They've given you this relation, this set of ordered pairs, this relationship between x and y as a graph. So all of these blue dots represent a point that belongs to this relation. So if they want the domain, who did we say yesterday the domain was going to be? If you're here and you know, you can just say it. The domain is going to be all the what values? The x's. So literally they want us to make a list of all the x values that live on this graph. So guys, we're not looking at ordered pairs. We're going to have to pull them off of the graph. So give yourself your best curly brace, and we're going to make a list of all the x values, all the x coordinates that live on this graph. So since x's move left to right, I'm just going to work from the left point across to the right point. So at this blue point, it has an x coordinate of -3. So -3 is the first x value that lives in this domain. All right, the next blue dot, actually there's 2 of them that have the same x coordinate. They both have an x coordinate of -2, and we only list it once because we don't list repeats. All right, the next blue dot is right there, and that one has an x value of -1. The next blue dot is right there, and it has an x value of 0. All right, the next blue dot is right here, and it has an x coordinate of 1. And then the next blue dot is here, and that one has an x coordinate of 3. And the last blue dot is all the way up here, and that one has an x coordinate of +4. So that's your domain. Those are all the x values that live on the graph of this relation. All right, now they want the range. Well, that's kind of easy now. If the domain were all the x's, the range is going to be all the y values. So now we have to go and grab all of the y values that live on this graph. So since y's move up and down, I'm just going to start at the low dot and work my way up to the high dot. All right, so this blue dot has a y coordinate of -3. All right, the next 2 blue dots both have a y coordinate of -2, but we only list it once because we don't list repeats. All right, the next 2 blue dots also share a y coordinate of +1, and we don't list repeats, so we only list it one time. All right, the next 2 blue dots also have the same y coordinate of +2, but we only list it once because we don't list repeats. And then the last blue dot all the way up here has a y coordinate of +4, and we only have the one, so we're good. And then we close it. So your range are all of those y values. Everybody at home, are we okay? Can we see? Okay. All right. Everybody here is good. I feel like I wish I could remember. All right. Function. I want to know whether this is the graph of just a relation, or is it the graph of a relation that represents a function? So it said, if you're looking at the graph, see if it passes the vertical line test. Guys, if I draw a vertical line right there, how many blue dots does it hit at a time? Just one. That is showing you that this x value of -3 only makes a y coordinate of 2 come out. -3 only produces that one output. If I draw a vertical line there, how many blue dots does it hit? Just 1, right? This is telling you that this x value of -1 only makes a y value of 1 come out. This x value only produces 1 output, right? But if I was to draw a vertical line right here, now how many dots does it hit? 2. That is so not good. That is telling you that if you were to plug -2 into this equation, it could make a positive y value, a positive 1 come out, or it could make a negative y value, a -2 come out. And is that a function? If one number going in could make 2 different numbers come out? No. So the vertical line test is showing you that, hey, the x's repeat here, this x value makes 2 different y values come out. That is definitely not the graph of a function, okay? All right, perfect. All right, so look at example B. Just for time's sake, guys, I'm not going to make us do the domain and range. The domain would literally be you guys listing the x's. The range would be you guys listing the y's. And I'm pretty sure this is a typo. They shouldn't have listed a number that has no correspondence. So I don't know why that's there. I'm like 99% sure it's a typo. All right, and then the range would be the y values. I don't think we need to practice making these lists, so I'm going to skip that part. I just want you guys to look at this example and tell me right away, is this the mapping diagram of a function, yes or no? Think about it, look at it, and you tell me what you think. Look at what it's saying. It's saying that if -3 went in, he would only make 0 come out. When -2 goes in, it would only make a 2 come out. When -1 goes in, it would only make a 6 come out. When 0 goes in, it would only make a 4 come out. And when +1 goes in, it would only make a 6 come out. Each input should only be pointing to one number. If all of a sudden this pointed to 2 different numbers, would that be a function? If -3 could make 2 different numbers come out? No. But since everything is only pointing to one number, is that a function? Yeah. Yes. Yes, it is. Remember, we don't care if the y gets used more than once. We just don't want any of the x's to repeat. We don't want the x's to be used more than once. But that's definitely the mapping diagram of a function. Okay, look at example C. Now they've given you a relation listed as a set of ordered pairs. They've just given you a list of ordered pairs that make up this relation. All right, so now they want the domain and range, right? We're going to skip that part. The domain would be all of the x coordinates. The range would be all of the y coordinates. We would just make those lists. We don't need to practice that. All right, if we had more time, I would totally do it. I just want you guys to look at this list of ordered pairs and tell me whether or not it represents function behavior. So guys, look at it. These ordered pairs are telling you a story. This ordered pair is telling you that when -6 goes in, he makes a -1 come out. Do you see another ordered pair that says -6 goes in and he also makes a different number come out? No. This ordered pair says that when -5 goes in, it makes a -9 come out. Do you see another ordered pair that says -5 goes in and makes a different number come out? No. This one says -3 goes in, he makes -7 come out. Is there another ordered pair that says -3 goes in and makes a different number come out? No. This ordered pair says -1 goes in and 7 comes out. Is there another ordered pair that says -1 goes in and now a different number comes out? No. And then the last ordered pair says that when 6 goes in, -9 comes out. Is there another ordered pair that says 6 goes in and now a different number comes out? No. Every single x value is only telling you that one y value comes out. So is that a relation that shows a function? The answer would be, guys, if you're here, we can say it. Yeah. Yeah! It's definitely showing you a function. Okay, are we okay at home? Yes? Okay, let me move my screen up. I'm dying. It's easily solvable. I can just stop talking. But I can't do it. Okay. Oh my God. I'm just stalling, guys. I gotta catch my breath.
I keep doing that.
You're fine.
I keep hitting the microphone instead of the camera.
Okay. All right, here we go. Look at D. I've given you a mapping diagram. They want the domain and the range and whether or not it's a function. Again, we're going to skip this part. The domain would be all of the x's, and they always list the x's on the left, so it would just be a list of these numbers. Then they want the range, which are the y values, and the y values are always put on the right. So it would just be a list of the x's and the y's. We can skip that. I just want you guys to look at this and tell me whether this mapping diagram represents a function. Do you think yes or no, it's the mapping diagram of a function? No, people here are saying no. Does anybody want to tell me who's the bad guy? Who makes this not a function? Two. 2 is totally a bad guy. This mapping diagram says that if you were to plug 2 into this equation, it could make a negative 2 come out, or it could make a positive 1 come out. That's not a function. That's not function behavior if one input can produce 2 different outputs. So that is definitely not the mapping diagram of a function because 2 ruined it. So that's a no. Everybody okay with that? So I feel like the mapping diagrams are usually the easiest ones to see that are the no's, because you'll see the 2 arrows coming away from an x, and you know it's not a function now. All right, I put an asterisk next to example E and example F, because you guys have to treat these ones a little bit differently. They're still asking the same questions. What's the domain? What's the range? And is it a function? The problem is, guys, on all of the graphs that we've seen so far, the dots have not been connected. When the dots aren't connected, those just specific dots make up the relation. So it's just these specific x values, it's just these specific y values. But when the dots are connected, now that means every single possible x and y value, fraction, decimal, positive, negative, any possible x or y value in this range could be in the domain or range. So guys, there's way too many numbers for us to be able to list on these lines. We couldn't sit here and list all of the numbers in between 1 and 2. There's infinitely many decimals there. So we couldn't possibly show this domain and range as a list. So when they connect the dots, you're going to have to show your domain and range as sandwich inequalities. Which we've already seen a lot from those compound inequalities, the ands, the sandwiches. All right, and how do we write a sandwich inequality? It's always little number with a less than symbol, then the variable, usually it's x, always a less than symbol, big number. Now here's the tricky part. Because you're going to be doing this for your domain and your range, when you're doing your domain, yeah, you're going to be talking about x's. But when you're doing your range, you're going to be talking about y's. So you might have to put a y in the middle if you're talking about the range, because Delta Math will mark you wrong, and so will I. All right, so here we go. Let's say I want the domain of this relation, right? Well, the domain means I want you to get all the x values that live on this graph. Like I said, I couldn't possibly sit here and list them all. So I'm going to have to write a sandwich inequality. All the x values on this graph are in between who and who. So guys, x's move left and right. So what you want to do is look at the graph and find me the farthest left it ever touched. What's the farthest left x value it ever went to? Anybody know? -2. All the way. Now what's the farthest right the graph ever went to? An x value of 6, I think, right? So that means you want to tell me the domain is any x value in between -2 and 6. So we're going to write that as a sandwich inequality. So little number, -2. Always a less than. Now, you see how it's a closed circle at -2? That means you want to include them, so put a line under your symbol. If it was an open circle, because Delta Math is definitely going to have open circles. If it was an open circle, then you wouldn't include -2, and then you wouldn't put a line under that symbol. But since it's a closed circle, you want to put a line. Now, if it's also, like let's say the highest spot, like here, it's not necessarily a dot, but it's the highest spot. That would also be included, because it's a spot the graph goes through, that would also get a line under the symbol. The only time you don't put a line under the symbol is when the circles are open, okay? All right, and then we're talking about x's, right? So put an x as your variable, and then always a less than. Who's the biggest number we said x went all the way over to? 6. And since 6 is at a closed dot, put a line under it and include it. And that's your domain. X can be any number in between -2 and 6. Because like I said, you couldn't possibly list all of those numbers because of all the decimals that are in there. All right, now we go to the range. The range are our y values. Y's move up and down. So now you want to find the lowest spot the graph ever went to, up to the highest spot the graph ever went to. So guys, what's the lowest number this graph ever went to? Negative. That's a y value, that is? -1. And then all the way up to, what's the highest y value it ever reached? 3. So now your range is any number in between -1 and 3. So little number, -1, less than, and since -1 was at a closed dot, we want to include it. And now here's the tricky part. Make sure you put y in the middle this time, because you will get marked wrong if you put an x. And then always a less than. And now who do we say the biggest y value was? 3. And since it happened at a closed dot, put a line under it. And then that's your range, any number in between -1 and 3. All right, guys, now I want to know, is this the graph of a just relation, or is this the graph of a relation that represents a function? Does it pass the vertical line test? Can I draw a vertical line right here and it only touches the graph one spot at a time? No, this one touches it here and here. That means that when this x value goes in, it could make this y value or that y value come out. So is this the graph of a function?
No.
No, it fails the VLT everywhere. All over the place, it's failing the VLT. This is definitely a no. All right, I want you guys at home and you guys here to do F. Get me the domain, the range, and tell me whether or not it's a function. I'm just gonna give you a couple minutes, and then I want to show you one homework problem, and we're done. And I'm gonna get some air. Oh my God. I don't know if I can do this. I really don't. Was sitting better? Like why? I didn't feel like I was this out of breath yesterday.
Probably sitting, yes, because you're moving around. You're exerting more energy by standing up.
I gotta get out of that chair.
And also, you're at like super pace today.
I guess I feel like I am rushing. I am. I just feel like I want to cover so much, and I just.
Yeah, like you were generally going slower yesterday.
Oh my God. Kat, how you doing? All right, so farthest left, you got a mark. So this would be -6 to 5, and then the lowest would be, remember, it doesn't be dot to dot. It would be -4 all the way up to, I think, 6 maybe? And then you want to write those sandwich inequalities, little number to big number. Again, it doesn't have to be point to point, right? The farthest left was here at -6. The farthest right was here at 5. But then the high and low points, the lowest is here at -4, and the highest is up here at 6. So it doesn't necessarily have to be at a dot to be the highest or lowest point. And then again, the only time you would not put a line under your symbol is if it was at an open circle. Black dots, and then even parts that it just passes through, part of the graph, those are always included. They always get a line under the symbol. All right, everybody at home, are you okay with those domains and ranges? Okay? Now guys, tell me right now, would this graph pass the VLT? Is this the graph of a function? Totally, totally. You can draw a vertical line anywhere you want. And it's only touching it at one point at a time. This is definitely showing the graph of a function.
No.
Okay, the only thing I want to show you is a homework problem on Delta Math. I just feel like the wording is crazy, so I want you guys to see it before you leave.
It's how low the graph goes or how high the graph goes. So this would be your lowest number, would be -4 over here, and then your high would be the highest number here, which I think is right, or 6. Okay, but otherwise the other one is fine. The other one is the dots because that's the x values. Okay. So it says y here.
Thank you. Okay. All right, guys, so tonight you have a homework assignment on Delta Math. It's 13 questions. It's like 4 questions from one topic, 4 questions from another topic, and then 5 questions from a third topic. I did not put a penalty on this one, so it's literally just keep going until you get 13 correct, but you should be able to get there faster because I'm pretty sure that the penalty was actually making you do 2 extra for each one you got wrong. And I don't think that's necessary. All right, but you're looking to get 13 questions correct. One of the topics is going to be looking at a mapping diagram. Can you tell whether or not it's a function? But it's these drop downs they make you guys put in. So I wanted to kind of go through this with you. So guys, everybody look at this mapping diagram and decide whether or not you think it's a function. Is this the mapping diagram of a function?
Yes.
Totally, right? He only makes one, he only makes one, he only makes one number, and he makes one number. Who cares if 2 different numbers make the same number come out? That's okay. I just don't want this number pointing to 2 different outputs, okay? All right, so the way they do it in a mapping diagram, it's always the x's or the inputs that are on the left in set A, and then it's always the y values or the outputs that are in set B. So watch this. This is what you're going to have to do to say this is correct. First things first, it's going to say the mapping diagram above represents a function or does not represent a function. We said it represents a function, so click the word represents. All right, it represents a function since for each number, you're talking about what each number in set A is doing. You always read it from set A to set B. So for each number in set A, but you want to make sure you pick the set A that says they are showing inputs. So make sure you pick the one set A that says input there. Now, it's a function because the numbers in set A only point or only map to one number in set B. So you want to say there is only one mapping. They're only pointing to one number in set B, which are the outputs. So make sure you pick the set B that says output. So take a look at that. I just wanted to kind of go over that vocabulary with you guys so you weren't feeling like you got thrown into it alone on the first go round when you start doing your homework. All right, then you can hit submit answer. It'll say, yes, I want to submit that, and you'll get your green check. All right, so I just wanted to go over one with you so you guys could see that. Do you guys see what I'm talking about at home? Are you okay with that? Okay, so you're probably going to have 4 questions like this out of the Delta Math. 4 questions where you're determining, I think, domain and range and writing them as sandwiches. And then I think it's 5 questions about, I think, ordered pairs. Looking at ordered pairs and telling whether they represent a function. All right, but it's due tomorrow night at midnight, okay? Or 11:45 maybe. All right, if you guys are good at home, you guys are good to go. Otherwise, please stay on and ask me any questions. But thank you so much for being here.